Hello and welcome to PTC Express Video Tip of the Month. My name is Leo Green. Today we're going to be talking about flexible components or flexibility in components, as well as the warp feature with respect to flexible components. So let's jump right in. What you see here is a cabinet, and the cabinet obviously is a very simple idea or mechanism in this case, but the idea here is that you might have an assembly already in place where you use skeletons perhaps to get going. You got your mechanism, you got your design partway or nearing completion, and what you'd really like to do is start to add the detail hardware that you left out early in the design. Very, very rarely would you start with nuts, bolts, and hinges and things like that you're going to find on the shelf. Well, in this case, let's take a look at what the hinge might be that we're going to apply here. The hinge is already three pieces making up the hinge, and you can see here we've got a offset parameter where I can update the model and have it at various angles and so on. But I didn't set it up as a mechanism. Now, why wouldn't I set a hinge up as a mechanism in this case? Well, a hinge as a mechanism applied to a mechanism that's already in place would have redundant connections, which would likely cause performance impact or perhaps even cause the assembly to fail. So I would leave those out, especially since a hinge would be an assembly of its own that would likely to be off the shelf or maybe part of a family table that you'd like to replace. So let's take a look at what you might use flexibility for with respect to this hinge. Through the Edit Setup menu, you'll get a menu manager that shows the flexibility option. Now, flexibility option allows you to add all kinds of stuff regarding what will be different in its instance as applied. So in this case, what I have is that value, the angular value for the hinge. Okay, so what does that mean? Well, when I add this hinge subassembly, and I'll do that now, so if I say, give me a new component, and I'll bring in the hinge assembly, first question you'll see here is that the hinge already has a predefined flexibility. Do you want to use it? I'll say, yeah, let's go ahead and use that. And I'll specify perhaps a new value if I knew what the value was. But in this case, I'd like that value to be updating depending on my assembly. So let's take a look at some of these methods. On the method drop-down, you'll see not only can I specify a value, but I can also ask ProEngineer to measure the length of the curve, a distance, or perhaps an angle. And so in this case, we're going to measure an angle between the face of the cabinet and the current angle of the door. And you'll see it makes an analysis, and you'll see it's got the short angle. I'd really like the complement, so I'll just flip the arrow there, get the complement, and now watch the hinge. Where's the hinge showing? Here. There's the hinge. See how the hinge updated to accomplish that angle. So now when I assemble this, that face, let's bring it down to here. I'll put on the axes, which might be part of my skeleton, for example. And I'll drop in axes here to here. And let's add one more thing. Add another constraint for an offset from this face to perhaps that face there. We'll flip that and we'll drag that down. Okay. So I've now added a new subassembly, but it's a flexible component such that when I move my door, the component updates. So I haven't altered my connection for the door, and I still have the ability to add a flexible component. What does this mean? Well, this means that this hinge can exist, the same subassembly can exist multiple times in my subassembly, or in this subassembly. Let's slip that down a little bit. If I edit the definition, I can just drag that down a bit. Let's do that, because I've assembled a couple more in here, and I'll bring those back now. So you see how these hinges all exist in this assembly, and no matter what I move, this way I might move this one up, might move this one down, take this one over this way a little bit. When I say I'm done, all of the hinges update appropriately. Okay. So there's flexibility with respect to a subassembly. Most people think of flexibility with respect to actually modifying geometry, making something a little bit longer or shorter. Let's take a look at something else now. Let's say I've got a subassembly here that might move as a function of the door. You see how it moves? And I might put a spring along the shaft, perhaps a bellows or something along those lines. So let's go ahead and do that now. What if along this stroke assembly I want to apply a bellows? Now this bellows could be pretty complicated geometry, and I want it to extend or shrink as a function of the length of that stroke subassembly. Now with respect to a spring, for example, you could do it with a helical sweep, and a helical sweep is going to give you a specific pitch. I could then modify the length of that spring, but if I make it longer or shorter, it'll change the number of turns, and so I wouldn't want that to happen. But let's take this example, which is even more complicated. I'll insert here a warp feature, where I'll specify I want to warp the entire solid with respect to, and I'll go to my direction collector and pick a plane. So I'm going to add now a warp, and in this case, well, let's take a look at a couple of them. What if I want to do a warp as a bend? Well, you see the box here. The box is what I'm going to drag. I want to drag the other end, and I want it to be, this is about where it's going to modify. So let's take a look at what this might do. Notice here now that I can take this complicated geometry and I can just give it just a quick bend, and that's going to give me an angle, and if I click this box, it's going to give me an angle parameter that I could use for my flexibility. But in this case, I just want to do a compression. So let's go to the list, take away the bend, and add a compression. And now I've got a compression, or an extension, where I can vary the length of this thing as a function of the length. Now in this case, it's a function of scale, and this gets to the cool little technique or tip or trick that I'd like to show you. Okay, so I've got the bellows assembled to my stroke assembly, but it's not quite the right length, and so this is where we get to the little trick. I'm going to insert, just before the bellows, a curve that I'm going to sketch on the assembly plane, utilizing as a reference this face as well as the axis. And let's use this face as well. So I'm going to sketch now a curve that's going to represent the ratio so I could use it for the warp feature. And I'll do that by adding a dimension from one known reference to another known reference. That's going to give us a known dimension. So now when I go to Tools and Parameters, or Relations, I can say that SD0 is going to be equal to KD1 divided by 9, which is the length of the bellows in its in its manufactured state. So now I'm just going to bring back the bellows, edit its definition, change its flexibility from value to curve length, and I'm going to pick the curve that's down in there. Now the bellows will be the length as described by the geometry. So let's change its length, regenerate, updates, drag it again, regenerate, and updates. So what does this mean? Now when we go back to the cabinet assembly and put it in the assembly here, when I regenerate, everything updates just like you'd expect. Okay, so I hope a little of this made sense to you. I know I went through a lot of stuff kind of quick, but a couple of tips and techniques for flexible components as well as the warp feature. My name is Leo Green. I hope that we can get together at some point down the road. Have a great day now. Bye.